thank you so much for having me. It's a great introduction from TMA. Thank you so much. Yeah, well, flooding and climate changes. The flooding affects the urban areas and infrastructure and causes both direct material damage and casualties, unfortunately also, but also derived economic cost, example given, for example, delays on transport sector due to failure on infrastructure. Climate changes increases the frequency of flooding events, more heavy rainfall, river discharge, and mean sea level rise, and causing higher storm surge events. Existing urban areas and infrastructure must adapt to the future situation. And new urban areas and infrastructure need to be planned to comply to the prognosis on climate development. Next, please. Yeah, I've been working several years in Tanzania, and this is for one of my projects. This is the Zimbabwe River. It's a relatively large river, large catchment crossing through Dar es Salaam. And here we can see just a couple of pictures so you can get an idea how it looks like. Next, please. Here we see easily in the terrain model we have produced for the river valley. So you see here closely that there's a Morogoro road that the river crosses. It's one of the main roads in order to cross the river valley. Next, please. Here we see also shown before in the previous presentation, but it can go really bad sometimes. And this is one of the recent floods at that time when I was there in Tanzania, and it had several fatalities, but also the BRT line, the bus depot where all the BRT lines buses are stored, was flooded in this event, which caused massive damages, and there were massive damages on housings as well. Next one. So we got a project out here there through a World Bank finance project at that time, in order, because Zimbabwe River, we needed to figure out what to do in order to improve the conditions there. To the map in the right side, you can see that there were several improvement tested out here. We tried to derive the current of the river, to cross several places on this infrastructure, in order to quickly at these extreme events get the water out at the ocean as fast as possible. There was also several other activities going on at that time. They were planning on building in the floodplain, as in the valley. So we need to figure out if that was possible at all. Next, please. We take these terrain models and combine them into hydrological models, and this is some of the model results for several of the tested scenarios. And where we could see from it that with many of the different mitigations we did, of course it improved, but there was no guarantee that this area would be a dry area. Next one. Yeah, then we have done another. We have also looked at the transport sector. We've done the traffic model of Dar es Salaam, and then we combined it with the flood model, which is interesting. They wanted to know what is the economic cost on these different prognoses on climate changes. So we have things like precipitation, and we have the sea level rise, and all these different parameters. Next, please. Then we put it into a software we have developed together with the university, where you can quickly get out modeling results of floods. And to the left, you see combined of river flooding and heavy rainfall over Dar es Salaam. The blue one is 16 millimeters for 24 hours, I think. And then you have in the other side, you have the storm surge level here. It doesn't affect too much Dar es Salaam. Next one, please. Yeah, so here we have what the input for the study of the transport model. We have in the left side all some of the rainfall intensities we've been looking at all over the urban part of Dar es Salaam, and also for the storm surge and the right side. And if you take the next one. So here the interesting part is that with these models we are combining, so that every time we can mark out, here we have all the BRT lines and so on, and other access roads that we were supposed to analyze. And here we can see disrupted intersections due to different rain events. So we are combining the flood models with the transport models, and then we are figuring out where the disruptions are, and based on the disruptions we can calculate the possible delays. Is it possible at all to cross if there's no other D route and these kind of things? Next, please. Yeah, so here we just see when we are getting more and more rain events. Here we have another rain event and another rain event going on. We get more and more disruptions, and if it's not possible for the transport sector to do a D route, they will have to wait until either the road is fixed, or that they get another way to get to their to the point where they deliver the goods, for example. Next one. This is just to look at it. It's put here. We have also taken impact scenarios based on at that time climate prognosis. So we have the 2016 basic scenarios, and we have 2050 where we have done future prognosis with climate factors. So here's to see how the changes in percentage of costs due to these different rain events, and it's of course it's shown here that it's quite obvious that for some of the rainfalls it's a really big cost because so many roads are blocked by the water. Next one, please. Yeah, so the outcome here is flooding and climate changes that exist in urban areas, and infrastructure must adapt to future situations. Either adapt or relocate it. And new urban areas and infrastructure need to be planned according to the prognosis on climate development. If you're, for example, building a railway or building a bridge or an airport or something really major infrastructure and expensive infrastructure, you of course need to be sure what are you doing according to the future prognosis. And easy access to data, that's actually one of the main points here. Easy access to data and governmental approved design criteria and guidelines regarding climate factors will ensure and enhance the climate resilience of infrastructure and urban areas. So I think that was more or less thank you so much for listening to this.